Of the day. Here, myself, Shrikant, Ameya, Sunil, presenting for our final group project, Conversational Agent for Recommender System. So, traditional recommender system usually struggle to capture user preferences. There are no personalized choices which it can offer, and not even LLMs can do it up to a certain extent. So, this project introduced a personalized agentic query-based movie recommender that uses LLM-driven dialogue and dynamic user profiling for tailored suggestions. So to understand a high-level methodology, the user will interact with the agent and the LLM system, and these system will be in connection with the database. Here we are using DeepSeek and MySQL as the database, and after certain interactions, it will recommend a movie.
Hi, I'm Shivaraman, and I'll be continuing more on the architecture here. So basically, how the model starts off is the user will interact with the LLM. It'll give it a certain query, and the LLM extracts words and phrases out of that query using parser, and those words are fed into the agent, where the agent will have a back and forth communication with the user to get a uh, more refined data on how to handle this query. And this particular way of training is zero shot learning, and this is done so that the model will have more label data to train itself, and fine tuning it more and more will help it jot down on what actually the user wants, and give him or her a more refined result in the end. And this chain of thought is done basically because, say, if you're interacting with anyone and you want to know just the answer for what is 12 into 15, and they say it's 180, you won't really know how they got into that particular answer, right? So you might need someone to break it down step by step, like how 12 into 10 is 120, and 12 into 5 is 60, and if you add them up, you get 12 into 15, which gives them 180. So this chain of thought helps you understand the problem better, and that's the same for an agent too. So the agent and the user will have back and forth communication on what sort of result the user expects. So, and this data is fed into the model, and it extracts more and more keywords out of this. And once it finally has all the information it needs, it will run a search. And basically, the LLM we are using here is DeepSeek, and the cutoff for this particular LLM is 2020, June 24. And to get a more refined recent search, we use an RAG model which gets recent experiences of the web based on the search which is needed in this particular scenario, and that is fed into the recommender system. And based on whether the user is a new user or not, the recommender system is in connection with the database MySQL over here, which contains all user data. And if, say, it's a new user, all the new trending examples or new trending results of the user search is given to him. But if it's an old user, based on his or her previous searches, the result will be more refined, and finally the results are all filtered out and given to the user, which is gonna be us. And as I said, the chain of thought and the zero shot learning is what makes this particular agent get a more refined grasp of what the user needs. So coming on to the next one, this gives an idea on what a usual context-based model will look like. So once the user, say, if you just go on a day-to-day communication of how people use ChatGPT right now, the user might just type a prompt saying, "recommend me for movies," and the model recommends you for random movies. It doesn't ask any sort of further questions, and The user won't really know if or not the movies which are being recommended to him is gonna be something that's uh, gonna be his it's gonna be nice or not anyway. So this particular model, it sort of engages a conversation like how you would have with a friend or someone you know, and you would ask your friend or your colleague on what sort of movies, what sort of new TV shows they watched, and if or no they would recommend it to you or not. And this is how this model is brought out to be. So this model engages in a conversation with the user to get an idea on how, what exactly the user wants, and after a series of computations, it finally recommends the movie based on the user's preference, his w- if it's popular or not, what age group he is in, what sort of variety of movies he likes, and all these conditions are taken into consideration, and finally the model recommends whatever the user initially wanted. So that's how this model works. Now I'll pass on to my friend who will continue with an example of how our project works.
Thank you for explaining that. Now I will show how our implementation works and how it is different from the usual LLM models. The user gives the same prompt like recommend me 4 family-friendly American movies. The LLM parses it. The extracted keywords and phrases are sent to recommender system and the agent. Based on those, agent asks some series of questions to the user, and then depending on the user's answer, uh, we will work with the preference framework. So the user gave the answer asking for the latest from last 5 years movies. So all these answers will be first fed into the preference framework, as it is the first preference, so that is the first choice of the user, which will make our recommending more personalized. And since it is asking from the latest 5 years and DeepSeek has the cutoff at June 24, the RAG comes into the act. So these particular keywords and phrases are then again passed to RAG. It will do a internet search of what are the movies from June 24 to April 25, and it will give its results to LLM. Then LLM will again summarize it and extract the keywords and phrases from it. Now here we can see the RAG have given some movies here which are from last 5 years. So these movies will go direct, since these are movies, it will directly go to the database. So once all the movies are in the database, now the recommender system interacts with the database. It first takes in the knowledge where the user is new user or the existing user. For this example, we have considered it as a new user. Since it is a new user, it will first prefer first give and the recommendations which are trending or the latest ones. Now here from all the extraction from all the keywords, these are the recommendations made by the uh, recommender system from our agent. And all these movies are from exactly from the given time frame. Some movies are also from 2024, after June 2024. So this proves that our model, our agent, and works better than the DeepSeek and all other LLMs.
So to give you an idea on why our particular model, our recommender system is better than LLMs out there is because one, most LLMs have a knowledge cutoff period. So for example, GPT-4, the cutoff period is September 2021 in many cases, and though there are some new versions that are updated right now, it's still not as recent as you would expect it to be. So seeing as this is a recommender system and you would want movies that are to be recommended to the user, you would need all the data that is available until recent times to help in with the recommendation, and that's where the RAG steps in. The next is the LLMs don't usually have a structured database which allows it for precise filtering, sorting, and aggregations. So an LLM will usually provide answers based on probabilistic patterns and sometimes hallucinate or return incomplete data, which will be less reliable for applications where accuracy and consistency matter, like in our case. And the next one is a dedicated database can be updated continuously with new movies, ratings, or user interactions, while an LLM's internal knowledge remains static unless you fine tune it, which is more complex and expensive. And talking about scaling, so for recommendation systems, you often need to filter multiple criterias, multiple sub elements like genre, release year, ratings, and only after doing that you'll get a personalized result in the end. So traditional databases are designed exactly for that purpose with indexes and optimized query planners. And cost-wise, while it might be simpler to not set up a separate database initially, and relying solely on an LLM can be flexible. The LLM's souls, if we were to use the LLM as the sole source, you might need to call it with long prompts or try to extract structured data, which can be cost inefficient and again, as we said previously, challenging to scale. And giving it long prompts is not something the user would be willing to do, and the user, like any human, would just expect results which are simpler and easier for him or her to get in the end. So that's why our recommender system is in ways better than a traditional LLM. And to give you guys a demo on how our system works exactly, we have a demo video over here which I'll just run through. So right now we are just clearing up the system prompts, and now we'll run the Python version of it, and the assistant asks a question to the user on how it can help him today, and the user replies by saying if it can recommend him any movies similar to the movie Inception. And the assistant gives out questions like what sort of genre the user wants, sci-fi, action, or drama, and the user replies saying sci-fi. And the assistant, it runs a background search, it runs all these through parser, and it gives up other questions to the user if he wants a classic movie or a recent one, and the user replies by saying classic. And after the assistant gets this particular info, it will again in the end take this all in, feed it to its model, and hit him back with another question. So, is there any particular actor or actress we would like to see in this movie? And the user could reply saying, I don't have any preference for a particular actor or actress. And once he has done that, the assistant takes that into consideration and asks him if there's any particular director which the user likes. And say, for example, we give him Christopher Nolan, one of my personal favorite director, and once that is done, the assistant runs it all over, and in the end recommends him 5 movies which are directed by Christopher Nolan, which have a similar plot like Inception. And that's how our recommendation system works. So thank you so much for giving us this opportunity to display our particular presentation, and I hope you liked it.